أهلا بكم في قناتي SAT Math 800. Today's lesson is about transformation of a function. In this topic, we will learn how changing a function's equation affect its graph. We start with a basic graph called the parent function, and see how it moves, stretches, shrinks, or flips based on change in the equation. This change will follow simple rules. By the end of this lesson, you will be able to predict how graph looks just by looking at the equation, and it's an important skill that you have to know in the SAT test. First, we will start with translation, moving up and down vertical shifts. Vertical shift occur when you add or subtract a constant outside the function. We have here the function, the basic function is, or the parent function equal y equal fx, like this, without k. And we will add k outside the function, and we will show what will happen. If k is positive, k is greater than 0, then the entire graph shifts up by k units. If k is negative, the graph shifts down by absolute k units. We will take an example. If y, this is the parent function, y equal x squared, we're adding 3 to the function, y equal x squared plus 3, that shift the parabola 3 units upwards, placing the vertex to be 0 and 3. And if subtract 2 from the parent function, that shifts the parabola 2 units downwards, placing the vertex at 0 and negative 2. We will see. Now, this is the parent function. The parent function, always, its vertex is 0 and 0. When we add 3 to the parent function, that makes the parabola shift up, because it's plus, shift up 3 units, and make the vertex, what is the change in the vertex? The vertex change in the y coordinates only by the number we add. So it becomes 0 and 3. And if subtract a number, it will shift downward, changing the vertex, the y coordinates, with the number we subtracted. So the vertex becomes 0 and negative 2. Moving left and right, horizontal shifts. Horizontal shifts happen when add or subtract a constant inside the function. We have to pay attention to the difference between this and the previous translation. This translation moving left and right, and it moved horizontal shift. The previous translation moving up and down and vertical shifts. Horizontal shifts happen when you add or subtract a constant inside the function. That is the secret. That is the keyword of horizontal shift or vertical shift. If the parent function is y equal fx, the rule for horizontal shift is y equal, see here, we add or subtract inside the function. Here, k was outside the function. This is the secret. This is the keyword. When see that, it will move up and down, or vertically shift. We see the change inside the function, that will be moving left and right, or horizontal shift. If h is positive, the graph shifts right by h units. If the graph h is less than 0, then the graph shifts by absolute h units. Of course, there is no shift by negatives. So we take, this is negative h, so we shift by the positive number of h. If the function, the parent function, was y equal absolute x, subtracting x, see here, we subtract from x inside the absolute. The shift of the graph 4 units to the right, moving the vertex 4 and 0. Adding 1 to it, y equal absolute x plus 1, shifting the graph 1 unit to the left, placing the vertex at -1 and 0. We will see here, this is an absolute function. The parent is, the vertex is 0 and 0. When we subtract x, it moves 4 units to the right. That's opposite of what happened in the y-axis, in the translation on vertically. We do the opposite of this sign. This sign, when the change happen inside the function, the graph will do opposite of what we put. If we subtract 4, we will add 4 here in the x-axis. And the vertex will be 4 and 0. If we add 1, so we will move the function to the unit, 1 unit to the left, make the vertex -1 and 0. Reflection or mirroring the graph. If the parent function was y equal root k, which is only reflect for x greater than 0, there is no negative in radicand. The x here is the radicand, so there is, since it's square root, since x has to be x greater than or equal 0. Reflection across the x-axis means multiplying the whole function by -1. Take care, this is multiply all the function by -1, the sign affect outside the function. This flip the graph vertically. When we multiply the function from outside, it flips vertically. All positive y value becomes negative. Second kind of reflection is acrossing the y-axis, means reflecting, replacing x with -x. So here the effect will be inside the function. So it will be horizontal. Now we will talk about reflections or mirroring the graph. If the parent function is y equals square root x, which is only defined for x greater than 0, and this is, we discussed this in the previous video, the radicands must be greater than or equal 0. Reflecting across the x-axis means multiplying the whole function by -1. So we will multiply the whole function which is root x, multiply it by negative. This flip the graph vertically. All positive y value becomes negative. Now we will see reflecting across y-axis, means replacing x with -x. So the negative will be inside the root. This flipped the graph horizontally. Now it's only defined for x less than or equal 0. Why now it's negative or equal 0? Because we put negative inside the root, so the radicand must be positive. So negative and negative will become positive, and it open to the left. We know the previous video how to graph the radical, the root x. This is the parent function. It's drawn like that, y equal root x. And when we put negative or multiply the function, the parent function, with negative 1, it will reflect across the x-axis, make y equal negative root x. If we change the x with negative x, it will reflect about y-axis. We have to memorize all these things. Stretches and compressions, vertical changes. Vertical stretch and compression happen when you multiply the whole function by a number. You multiply the whole function, so it's affect from outside. Function by a number. The rule is, if the function is, the parent function is y equal fx, we will multiply it by a. If absolute A is greater than 1, then the graph stretches vertically. If absolute A is greater than 0 and less than 1, the graph compresses vertically, gets shorter and wider. This transformation changes the y value of every point. If the function, the parent function, as an example, y equal x squared, when we multiply, we are stretching or compression. So we multiply by a whole number or a fraction. When we multiply with a whole number, it's narrow. The parabola will be narrower. When we multiply by a fraction, it will be wider, parabola by half. We will see here, this is the parent, the green parabola is the parent function, y equal x squared. When we multiply it with fraction half, all this multiplication outside the function, half, so it duplicate. It is the purple parabola. When we multiply 2, it shrink the blue one. So stretch and compression. This is stretched one, this is compressed one. Stretching and compression horizontal changes. As we saw here, we multiply A outside the function. Here we will multiply horizontal stretch and compression happen when you multiply the input x, we will multiply x by a number. Rule is y equal f bx, we multiply b inside the function. If b is greater, absolute of course, absolute x is greater than 1, the graph compresses horizontally by a factor. It looks narrower and steeper. If absolute b is greater than 0 and here is and less than 1, here is wrong. The graph stretches horizontally by a factor of 1 over absolute b. Here we multiply by b, here we multiply by 1 over b. The multiplication happen inside with the x. The effect happen inside the root. If we multiply 2x horizontal compression, the graph rise faster, 1 over root 2, compression by 1 over root 2. Horizontal stretch will be root 2 if we multiply with fraction. Graph rise more slowly. We will see that. Now this is the parent graph. It's a radical, so this is the graph of a radical. The graph is y equal root x. If we multiply the x with 2, it's horizontal compression. It will be compression. If we multiply x with half or 0.5, the horizontal stretch. The graph rise more gradually. Of course, we can't release this in this graph, but if we redraw the whole graph, it will become obvious. Combining transformation, the importance of order. Of course, the order affects very much in this lesson. When you apply multiple transformation of a function, the order matters a lot. A good rule is to do x related change inside the function. X is inside the function. We start off inside the function first, then y related outside the function. The recommended order is horizontal shift. If there is a shift, we will start with the shift. It's minus or it's plus. We will start with the shift inside x. Horizontal stretch, compression or reflection inside the function, dx or negative x. So we will start all what happened inside the function. Vertical stretch, this is a multiplication outside the function, or vertical shift plus or minus the function. We will see now an example. Transform y equal x squared. This is x squared, and we want to make the steps to get this function, 2x plus 3 squared plus 5. What the first step? Of course, y equal x squared is the blue one. This is the parent function. We will, the step 1 is green, is add 3. There is at x plus 3. We said that we start with the what happened with x plus 3, so it becomes, there is a shift, -3. Then we, the subtraction, this is the orange one. Then we multiply by 2. It becomes stretching or shrinking. Step 4, shift up 5. So it was a parabola because it's squared. The squared is not one of the steps. We see what happened in the x. The x, we add 3 to the x, so this is the first step. Then we multiply, we inverse, reflect the x. Then we multiply the x. After all we have done in x, we add 5. So adding 5 is the last step. We have to solve a lot of exercise for this lesson, and I will make a video to solve a lot of exercise. Now, hope you enjoy watching this video. Don't forget to like and subscribe.